Hey everybody, so in this video we're going to look at the centre of mass for a non-uniform body, and this is where the centre of mass will not necessarily be at its geometric centre. If we consider a balancing point, if you want to balance a non-uniform rigid body, you would place the pivot at its centre of mass. If placed elsewhere, the body would rotate due to the resultant moment. So, for instance, when loading a truck or a ship, ensuring the even distribution of weight is essential for safety and stability. So we'll apply these ideas as we work through the three questions. In example 1, we're given a non-uniform rod of length 6 meters and weight 8 newtons, and this rests horizontally on two supports C and D. We're given that the centre of mass of the rod is 3.2 meters from C, and we've been asked to find the magnitude of the reactions at C and D. Okay, so there's quite a few things to consider here. First thing is, this is at rest, which means there's no vertical or horizontal movement. We also know that because it's not uniform, this 8 newtons does not act on the centre of this rod. We've been told actually it acts at 3.2 meters from C. So using all of this information, we can begin by resolving the vertical forces. We know the upward forces, RC and RD, will have a total equal to the downward force, which is 8 newtons. And we can come back to this equation later. Because it rests horizontally, this means that the resultant moment of the clockwise moment and the anti-clockwise moment is 0. So if we take moments about C, which is this point here, we'll look at the clockwise moment. Well, this will be the 3.2 meters multiplied by the downward force of 8 newtons. So 3.2 times 8 will give us a moment of 25.6 Newton meters acting clockwise. The anti-clockwise moment about C, well, this would be the force from RD. We don't have to consider RC because it's got 0 distance. So this will be the distance of 6 meters multiplied by RD, which is measured in newtons. So this will be 6 RD, Newton meters. Because it rests horizontally, we know the clockwise moment will be equal to the anti-clockwise moment. So 25.6 will be equal to 6 RD. And we can solve this by dividing both sides by 6. So RD will be equal to approximately 4.27 newtons. And now we can substitute this 4.27 back into our vertical forces here. So RC plus 4.27 will equal 8. So RC will equal 3.73 newtons. Okay? And in example 2, we're going to look at when a distance is unknown. Okay, so in example 2, we're given a non-uniform rod AB, has length 6 meters and a weight 120 newtons. We're told the rod is held horizontally at rest by two inextensible strings, C and D, where AC is 2 meters and AD is 4.5 meters. And the tension in the string, C, is 4 times the tension in the string, D. And we've been asked to work out the distance of the centre of mass of a rod from A. So this length here, which we've marked X. So perhaps you want to try this question yourself. You can pause the video, and when you come back, we'll go through the work solution. Okay, so welcome back if you had a go. So the first thing we need to do is resolve the vertical forces. And we're told it's held horizontally at rest, which means the sum of the tensions in C and D will be equal to the downward force. So resolving this vertically, we know TC plus TD will equal 120 newtons, and we're told that TC is 4 times TD. So we can substitute this for TC into here. We'll collect the like terms. So 5TD will equal 120. So the tension at D will be 24 newtons. And then we can substitute this for TD back into here. So TC will be 96 newtons. Okay? And I'm just going to include these on our diagram. So 24 newtons and 96 newtons. Okay, so now we need to look at taking moments. And I'm going to take moments from A, because then this will allow me to find X. If we look at the clockwise moments from A, well, this will be 320 newtons acting in this direction. So it'll be X meters multiplied by 120 newtons, which will give us a moment of 120 X Newton meters. And if we look at the anti-clockwise moments, well, this will be this length given as 2 meters times TC, so 2 lots of 96 Newton meters, plus this length multiplied by TD. And we know this length is going to be 4.5. This will be 4.5 lots of 24 Newton meters. And this works out as 300 Newton meters. Okay. And because we're told that it's at rest, we know the anti-clockwise and the clockwise moments will be the same. So 120x will equal 300. Divide both by 120, so x will be equal 2.5 meters. Okay. And in example 3, we're going to look at when the forces are not applied perpendicular to the rod. Okay, so in example 3, we're given a non-uniform rod AB of length 5 meters, and it's held in place horizontally in equilibrium by 2 light inextensible strings. They should say 2. The center of mass of the rod is 2 meters from A. We've been asked to find the mass of a rod, the angle theta, and the magnitude of the tension in the string at A. Okay, so there's quite a lot going on here. The first thing we'll look at is taking moments. And I'm going to take moments about A, because then this will negate this tension. So if we take moments about A, the clockwise moment will be given by mg times 2. So this will be 2mg. The anti-clockwise moment will be the length of a rod multiplied by a vertical force here. And we can work out this vertical force perpendicular to the rod, because using trigonometry, we're looking at the angle which is not contained. So this will be 16 times the sine of 60. This will be the force applied perpendicular to the rod, and we'll multiply that by the distance 5. This will be 5 times 16 sine 60, which is 69 Newton meters. I should also have included Newton meters here as well. And because we're told it's in equilibrium, the anti-clockwise moment will be the same as the clockwise moment. So 2mg will equal 69. We'll divide both by 2g, so therefore m will equal 3.53 kilograms. Okay. Now we need to find the angle theta. To do this, we can resolve the vertical forces and the horizontal forces. If we begin by resolving the vertical forces, so we need to find the vertical force applied at A. And again, because this is not contained within the angle theta, this will be T sine of theta. So we know that upward forces, t sine theta and 16 sine theta, must be equal to the applied downward force, mg. So t sine theta plus 16 sine 60 must be equal to mg, and m is 3.53 times g of 9.8. We can work this out and move this to the other side. So t sine theta will equal 20.7. We can call this equation 1. So because we need to work out t and theta, we have two unknowns, which means we need two equations. We can get the other equation by resolving the horizontal forces. So if we look at the two forces we've got this force T and this force 16 newtons. We've worked out the vertical component. The horizontal components do contain the angle. And this horizontal component will be T cos of theta. If you remember that if it contains the angle, it is cos of the angle. If it doesn't contain the angle, it is sine of the angle. And for our other force of 16, this will be 16 cos 60. And because it's held horizontally in equilibrium, these two horizontal forces must be the same. So t cos theta would be the same as 16 cos 60. So therefore, t will be 16 cos 60 divided by cos theta. And we'll call this equation 2. So now all we need to do is substitute this value of t into our equation 1 up here. So if we substitute this into here, we have 16 cos 60 over the cos of theta multiplied by sine theta will equal 20.7. We know sine theta over cos theta is tan theta, and we can move this 16 cos 60 to the right-hand side. So this will give us tan theta is 20.7 over 16 cos 60. And when we work this out, tan theta is 2.59 approximately. We'll take the arc and tan off both sides, so theta is approximately 69 degrees to the nearest degree. So finally, to work out the tension in the string at A, well, we can substitute this value of theta into our equation 2 to work out the tension. So the tension will be 16 cos 60 over the cos of 69, which gives us a tension of approximately 22.3 newtons at A. Okay? Well, thank you very much for watching. I hope you found that useful. If you did find that helpful, please like and subscribe. And you can download the full lesson and worksheet from my website, mrmathematics.com. There's a link in the description below. Thanks again, and take care.